So let's now talk about the basics of dimensional modeling. Why use a data warehouse? Data warehouses became popular for offloading reporting to another set of system resources. Dimensional modeling was created to help speed this reporting. Data applications are sometimes created for a small project at a company, and then over time it's expanded into an enterprise system. And the system has such a wealth of information that more and more access is requested. Online transaction systems are for inserts, updates, and deletes to be sped through the database. When reports become more common than data entry, the relational database system resources, they start to get blocked, and this is in order to maintain the integrity of the data. The reporting starts growing and growing and growing, and more requests start coming into the system. The resources are then strained on these servers, and sometimes it's picked to just add more memory and more CPUs. A normalized database structure for OLTP systems is designed for integrity and not for speed of reporting. The data warehouse was created for reporting. It offloads these reporting options to new resources. Usually, a data warehouse is created also to consolidate data from different systems. This helps the reporting tool to be able to select the data from one central location. The speed of the reporting in the data warehouse is good because mainly you are reading data from the system. And the processing of new data is usually done off hours. So, what is dimensional modeling? And why do we need dimensions and facts? Dimensional modeling was created to help speed the reading of data and reporting. It is optimized for the reporting of this data. Also, when you design dimension and facts and you view it in a conceptual model, it is easily viewable by other users. The cube and tabular design from analysis services databases is what was created against this dimensional modeling. The dimensional modeling is perfectly designed for our cube or tabular model in analysis services. The important thing is to clearly define the measures in the model. Additional measures not in the table can include counts or distinct counts of the fact table rows. Formulas are also created from these measures, like sales minus cost, to give other users the ability to look at gross profit margin. Other special aggregations like average, minimum, and maximum values can be included. The slicing and dicing of data is one of the terminologies brought about by OLAP-type databases. Slicing and dicing means we are grouping, slicing, and filtering, dicing by the related columns from the dimension table. Usually these are called attributes or hierarchies. So now let's talk about the needed entities for our dimensional model. Examples of attributes in a dimension are like the demographics of a customer table. These can include columns like number of children, yearly income, or even a hierarchy of geography like city, state, and country. The date dimension is usually a required table in a dimensional model. All transactions are usually done across time. And here we'll have columns or attributes like year, quarter, month, and the actual day. The reseller table can have a hierarchy like group, country, and region. This shows us sales by territory. Facts are created to relate to the dimensions, and they can include columns like sales or order quantity, and then the analysis services database will compute gross profit margin or even something like monthly sales quota. The gross profit margin will be generated, and this value can be a ratio to look at the difference between sales and product costs. On top of gross profit margin, we can create something like a key performance indicator or KPIs. And this is needed as a comparison value and will be something like the monthly sales quota. Lastly, and really most important in a dimensional model, is the grain of the measures. In the examples we will look at, we will see the grain being the sales order line item, and that is where the amount and quantity come from. The grain of the fact table is important, and remember, design to the lowest possible grain. Do not be afraid, though, to create sometimes what seems as a copy of a fact table that might have a different analytical meaning. All right, let's talk about a star schema model. In dimensional modeling, you'll hear the terms star schema as well as snowflake schema. The star label for a model comes from the visual display of the fact table related to the dimension table. The fact table's granularity will be based on the surrogate keys from the dimension table, and those have relationships to the measures. There might be other business keys that make up the primary key of the fact table, but the grain is based on these dimension keys. The measure in the fact table or measures are columns like sales amount and order quantity, and then in the analysis service cube, you will create the counts or distinct counts. Dimension tables consist of these surrogate keys. These are different than the OLTP system's business key. The fact that a dimension table can be a slowly changing dimension is one reason for using surrogate keys. Slowly changing is in dimension tables in order to capture historical data in the dimension table, like the price. The list price for a dimension might change over time, and the end user in business wants to know when that price time changed. Other reasons for having a surrogate key comes when the data has to come from multiple sources. This is when, like, two companies merge and they both have a product dimension. There we need a surrogate key in order to relate from the different sources. Attributes are then added to the dimension table as previously mentioned. Remember, design to the lowest grain. This is common now because the speed of disk and RAMs and the reduction in cost for these resources does not make hardware influence a dimensional model. So now let's go look at a demo in Visio of building a dimensional model. All right, let's start this demo with launching Visio. We'll click the Start button, start typing Visio, and pick Microsoft Visio 2010. Microsoft Visio provides a data model diagram template in order to use and help us with our dimensional model. We'll double-click that template, and it should open to a blank screen. The first thing I'm going to do is go to Design and change the orientation to Landscape to give us a little more room. And then in the bottom right, I'm increase the zoom level. I'm also going to move the database properties over to the right to give us a little more room visually. The first thing we're going to do is going to add some entities to our diagram. I'll start that by dragging the entity object onto our workspace. This will create a new table, and in our database properties, we're able to fill out this information. The first thing we'll do is give it a physical table name. We'll start with the fact table, Fact, Internet, Sales. We're not going to add any columns for now because that's going to first come from the surrogate keys of our dimension tables. I'm going to drag another entity onto our workspace and give this physical name table dim date. Date is usually the most common dimension in all dimensional modeling. Here is where we're able to slice and dice by year, quarter, month, and other attributes related to the date dimension. The first column we're going to add is the surrogate key for our dimension date. We'll call it dim date _SK for surrogate key. Surrogate keys are usually of an integer data type. They are required in a table, and or the primary key of the table. And in the notes, we're just going to say surrogate. The next column we'll add is the actual date. We'll call this actual date, and it's of a date data type and is required but is not the primary key of the table. We'll hold off from adding additional attributes for right now and add the rest of the tables for our dimensional model. We'll drag out 3 more entities, and we'll start by naming one of them dim product. This is our product dimension, which we mentioned earlier about a slowly changing dimension. The first column that we're going to add is dim product SK for our surrogate key. Again, it's of integer type. It's going to be required and is the primary key of our table. We'll name it surrogate and go to the next column. The next column is going to be our alternate key or the business key of the table. We'll call this product alternate key. We're going to make it a var-char, 20 characters, and it is required, and this is our business key. Again, we're going to hold off with the rest of the attributes until we complete the surrogate keys of all our dimension tables. The next table we're going to look at is going to be our dimension for customer, dim customer. And if you notice, I'll preface the dimension tables with dim, and I'll preface the fact table with fact. This is to help you easily visualize in the Object Explorer of Management Studio what these tables represent. We'll go to the columns property and we'll add dim customer surrogate key as an integer type, required, primary, and this is our surrogate. We'll also add customer ID, which is our business key, var-char 20. It is required, and this is our business key. Again, what we're doing here is documenting the conceptual design of our dimensional model. This is one of the most important steps in designing any analysis services database. With this documentation, other users will easily be able to see why we designed the dimensional model this way. The last table we're going to create is going to be for our sales territory, dim sales territory. Now, the only column we're going to add to this table is dim sales territory SK. And the reason that is because there is no name for the sales territory. It is a general table that shows us the group, country, and region of a particular sales territory. So we're just going to stick with the surrogate key for that table. I'm going to hide the database properties and rearrange some of these icons on our work area. I'm also going to zoom in a little so you can see what we've designed so far. So far we have the product dimension, the date dimension, sales territory dimension, and the customer dimension. In Visio, we can show relationships between the dimension tables and our fact tables. And if we drag a relationship object to the desktop and then point the arrow to the dimension and then the bottom half to the fact table, you will see that that surrogate key, because it's a primary key in the dimension table, will be added to the fact internet sales. We can do this for product and see it added as well. We're going to double click the fact internet sales to bring up the database properties, and we will notice that it didn't require this column in the table. By checking the required column checkbox, you will see the surrogate keys turn bold in the fact internet sales table. This is how you can indicate a column to be required in that table. Again, what we're doing here is designing a conceptual model of our dimensional model. this can be considered a data mart, and we might want to indicate that with a label. So I'm going to go and enter some text, and I'm going to call this our Internet Sales Data Mart. So why am I using the term data mart? In dimensional modeling, according to Kimball Group, each one of these sections of fact with dimension tables was labeled as a data mart. As you create more and more data marts, they will eventually become what's called your data warehouse. Also, some of these dimension tables will be shared between fact tables. So once you start building more and more data marts, you'll see that customer or something like date can be related to different measures in different fact groups. Because of this conceptual design and the work you do here, it will become visually appealing to you how these things are related.